Okay, well, thank you all for being here. So today we are going to present the new feature in geometric computation in version 12. Well, the key talk, this presentation will be just about showing what we introduced in this version. Geometry, we have been building geometry since version 10. And in version 12, we try to add, new constructors, more new operation, and improve the usability of the functionality. The earlier version highly focused on integrating the geometric object or geometric computation inside the Wolfram language from integration or numerical integration, integrate and integrate to ND-solve. All of them can actually take a geometric region and do computation on them, solve differential equation on them. In this version, we try more focusing on actually enhancing the geometric language and adding more constructor and such. So I will first start to present the new feature in terms of constructor, the new constructor we have. I will talk about the operations, the new angle operation, as well as the enhanced Boolean operation, and usability, how we kind of try to improve your experience while you are using the new functionality. So in terms of constructor, one of the key constructor actually we introduce is region. You can think about it as a, just a basic wrapper around any geometric object. And in the current version, one of the key features is that it allows you to auto-visualize any region. So in this example, I take a polyhedron, and you can just wrap region around it, and it should auto-visualize, which is not in my case. So if I just change that by a disk, for example, I get a function which, I get a disk, actually, disk object, which you can actually auto-visualize it, and you can actually compute on it. So for example, if I take the region of that output, I get pi. The key idea of introducing this wrapper, right, is first to allow you to just take a region, wrap it around, use region to wrap it around and then auto-visualize. But also in long term, we hope that it will allow us to actually enhance the, the feature we want for some of those geometric objects. For example, we should be able to add unit to your disk, for example, and do computation on it, and then automatically all the function from area and such will, apply the right unit and the right quantity on your output. And also it allows you to actually apply plot teams and other additional objects and other additional behavior to your geometric region. So I will look at the question in live stream here first. The question is about region 3D maybe. That's a possibility. So currently we are more thinking about just having a general wrapper which will handle all region independent of the embedding dimension. So the region wrapper will work both for 2D, 3D, or ND. So it's more kind of the general idea. We don't want to introduce a specific, or we don't want to introduce a constructor for each dimension, embedding dimension. So, and we just hope that the automation will automatically work. So that's roughly the idea of the region wrapper, and I hope for the future version we see a lot of functionality coming from it. As I pointed out, one will be the, handling of units and plot team and such. So the next set of constructors we introduce are more fractal region. So if you want to play with fractal region, in this case, you can do a Sierpinski mesh, for example. It works both in 2D and 3D. And actually, at the end, what you get is a mesh region. So you can actually visualize and purely manipulate it as any other mesh region in the system. We also have a Mengel mesh, which return you a Mengel mesh or counter mesh. So those are nice, base constructor you can use to manipulate. or construct geometric regions. Or in the same family, we also added space filling curves. So in this case, you can take a piano curve and essentially use an iterator and get a piano curve for any value of n. And it's a space filling curves. And you can actually take it and actually do computation on it. Like in this case, we kind of try to approximate the length of a piano curve, using fine sequence, because the length is actually a frequency equation, and you can actually automatically detect it. One additional constructor we added is angle path 3D, as you can imagine, coming from the 2D case of the turtle graphics. You can just essentially describe your path based on the different angle, and you can actually get some nice object like that in 3D. So these are kind of the set of base constructor we added, and you can combine them and also do more operation around them. So let's slightly talk about then the operation you can actually use to build more constructors. Oh, before we actually jump to the operation, I will first show you a quite interesting example here, which use the Wolfram neural network repository. So here we have actually a volumetric regression net for 3D face reconstructions. So it's actually currently available. So if you can just load it using net model, you can get a picture. In this case, we kind of pick Euclid picture because we are doing geometry, obviously. You can take it and actually transform it. And in this case, I reconstruct it and I get an actual 3D image. I just actually resize it and adjust it. And from that 3D image, you can actually convert it into a mesh region if you apply a dual machine cube, essentially. So you have a nice mesh region there. And if you canonicalize it into a polyhedron, and you can actually take that polyhedron and apply texture, and what you get at the end is a nice model of Euclid. So this is actually an actual 3D model you can take and send to your printer or manipulate as any other geometric regions. So this kind of shows how we actually able to integrate geometry into other components in the system, or you can take advantage of functionality in image processing and fit it back to geometry. And that, in this case, is through image mesh, which kind of allow you to make that bridge from a 3D image to a mesh region. Okay. Let's now look at all the enhancements we have actually in terms of operation. One thing we have been lacking earlier was essentially in terms of discretization was to be able to handle 3D graphics. So in this version, we actually added support for 3D graphic or discretization of 3D graphics. So you can take this graphic generated by parametric plot 3D, and then you can actually run discretized graphic on it. Oops. Beside the message from the plot range, you can actually get your graphic object there. It's a nice graphic object you can actually essentially manipulate and play with it. In this case, I can take it and actually just compute the centroid on it. Or I can just take it and use it back as a graphic 3D. And this is actually one of the features we added in this release, and this version, is that you can take a mesh region and just use it inside graphic 3D. You automatically recognize that it's a graphic 3D and plot it, essentially, or draw it. I think I probably have a custom plotting setup for these style sheets. That's why you see the difference between those two plots. But, well, let's just keep moving on that. So the next set I want to show is the enhanced operation for Boolean operation. I mean, the enhanced Boolean operation in these versions. So in this case, if you take the two basic platonic solid, the icosahedron and dodecahedron, you can actually just do a region union on it, and the result is a mesh region or a boundary mesh region, depending on the object you want. So in this case, it's a mesh region we wrap around the region wrapper, which I introduced earlier. You automatically get something which is nicely visual there, and you can actually manipulate it as any other region. You can do the same and compute the region intersection. So there you get the region there. Or you can do a region difference. And there you have actually roughly that cropping of R2 from R1. Or you can compute the region symmetric difference. So in this case, we kind of added opacity, so you can actually see how we have a hole inside there. And actually, the operation is actually correct. And this actually shows one of the nice features of the region wrapper. So in this case, you just do a region, you wrap it with a style and opacity, and automatically you get something nicely visual, but also you can compute over it. You can actually just apply, for example, an integrate on this object, and you get actually the volume of the object, or whatever, an integrate, the main integrand depend on. Okay. Next, related to the Boolean operations, are the region relations, right? So in this case, I take, two objects, an octahedron and a polyhedron, and we can actually just compare them. So what we introduce is, region equal, region within, and region disjoint. And hopefully in future version, we have more operation to actually compare region and such. Well, before I just go in detail of that, I will just take a question from the live stream. And one question is, will the notebook be available? I believe so, it'll be available, and we will let you know probably the URL where you can actually download that notebook. Okay, so back to region relations. So you can essentially take those two regions and ask, are they equal? So you get there false, or you can actually just visualize that. So you just have an icosahedron and octahedron there. So in this case, you can actually check the inclusion. Is region 2 included in region 1? So it's region within. And in this case, you also get a false output there, a region false. Or in this case, you can check if they're disjoint. And in this case, they tell you actually those two regions are disjoint. And if you plot them, you actually have two disjoint regions there. So those operations essentially work for any region. So including the basic region, graphic primitive, or mesh region, or a combination of them. Okay. So next, as I say, the first was enhanced constructor, more operations. And the last part we actually did was more about usability. So what we try to do is to improve your experience in terms of using geometric region inside the, inside the geometric framework or outside in other function, or as well as in the notebook. So in this case, I will show you the new interactive assistance which was added to mesh region. So if you generate a mesh region, in this case, I take an example data, the Beethoven, and I just ask, can you get a mesh region of it? If you click on it, you actually get an attached cell down there. And that attached shell actually allow you to look at property or to change the behavior, the rendering of your mesh regions. So in this case, the first cell there kind of show you the mesh, the different themes. So you can actually just press on it and then you get the set of lines. Or you can pick any plot theme from our different family of plot themes. And as you select it, you automatically change the cell and display a new version of that mesh. You can also, decorate that mesh. For example, in this case, we can add a bounding box there, or you can highlight some face and such, or you can change the viewpoint of the mesh by just selecting several aspects of from the cell. So from left to right, top to bottom. And if you want to actually 3D print that mesh, you actually have also a cell there where you can just essentially pick your printer. If you have a local printer or one of the provider we have, and then you can print on, press print, and then you can automatically connect to those online 3D service and print your model. And the last cell we actually have there provide you additional information of your mesh. So you can actually get the mesh dimension, the embedding dimension, the geometric dimension, as well as information about the cells, the different cells you have, and some basic information such as the area, the volume, the bounding box, and such. So we hope that this will kind of enhance your experience when you want to just, you import a mesh, you just want to look at it, or you want to change the way it looks like. So that was one aspect in terms of usability we added and improved in this version. The other, just one question I will take from the live stream before I switch to the next summary box. One question is there a way to simplify the region or polygon in any dimension? In the current version, we don't yet have operation to simplify the region and polygon, and it's actually in our list of features. We hope to probably be able to provide that in the coming release. Okay. Well, so back to our summary box. So in version 12, we added summary box for polygon and polyhedron. I will probably not dive into polygon and polyhedron functionality we added in 12. There will be a separate talk about that. But what I just want to show you here is the new summary box we added. So when you type now a polygon, what you get is a nice summary box with some set of information there. We give you the number of points, we give you the embedding dimension, and you can actually click on it, and then you get more information. Well, my style sheet have some strange behavior. I should probably double check that later on. And one key thing is that you can actually generate a bunch of them. Well, here I will use maybe 10. And they automatically nice typeset in your notebook. So this kind of enhance the, your experience in terms of playing with, large set of polygon or manipulating them. So you have there, a really nice, preview of your polygon and some basic information instead of just having a polygon with a set of coordinates. So we hope that this will enhance your experience in terms of playing with polygon and other objects in the system. Okay, one additional functionality we added, which I consider more in terms of usability, is be able to look at the base building block of a mesh region as a mesh region itself. In other words, if a point is a cell in a mesh region, right, and by itself you can look at it as a mesh. So in this version, we actually allow the whole system to understand that. So you can actually take any region. Well, in this case, I take an octahedron because it's kind of nice. It's a volumetric 3D object. And then you can just call any mesh operation on it. So you can actually essentially go back to the sub-mesh system, the subsystem, we essentially extended, we built for mesh region. And you can just ask him, what are the mesh primitive or the two-dimensional cell? In this case, it returns you the list of polygons. Right. So in other words, we don't need to build a new framework, for those graphic primitive. All of them, you can look them as cells, and then if you go back to that framework, which already have a lot of functionality, you can actually just manipulate those objects. So in this case, you get those cells. You can actually even just call highlight mesh and highlight, for example, in this case, the one-dimension cell, which are the line there. or you can highlight 2-dimension cells or just the point, and then you get the point there. So that we kind of allow you just to take an object as long as you recognize that is a linear mesh, and we have an obvious canonicalization as in term of mesh. We just take it and manipulate it in the system. And well, I kind of jumped that slide, but in the opposite direction also, you can actually take a mesh and use it in other functions like convex hole mesh, right? In earlier version, convex hole mesh just take a set of points and compute the convex hole. You can actually take a mesh and feed it to convex hole mesh, and then you're actually going to take a convex hole of that mesh right now, or you take a polygon and such. So we kind of allow you to move back and forward as long as the operation actually understand and can make sense of your input. Well, the last thing I want to show is more related to the integration I talked earlier. So in version 12, there's a lot of new functionality for optimizations. And as you know, several geometric problems actually roughly equivalent to an optimization problem. So in this example, show you some basic case where you can actually use our linear optimization or quadratic or cone optimization functionality to actually solve geometric problem. So here we are going to compute the volume, find the maximal volume of a cuboid, with axis parallel. So you can just take your, in this case, we generate a random polyhedron. You cannot just convert it into a linear inequality system, which is kind of roughly equivalent to having a half-plane representation of your polyhedron. Right? So a polyhedron is kind of an intersection of half-plane in this case. So when you compute those parameters A and B, you can feed them back to convex optimization, and then you have, roughly speaking, the equivalence problem then and solve it. And the solution actually gives you the maximum volume there. And essentially we use Cuboid essentially to kind of show you that you actually fit that cuboid inside that polyhedron. And the second example here show you how you can actually compute the maximal distance between two convex polyhedra by just using a quadratic optimization. Essentially, you want to minimize the distance. So in this case, you take the norm L2 over your polyhedrons, and then you just call it, and you essentially get your output. And here visually, we actually show you that minimal distance and the 2 closest point. So in short, there is a lot of functionality we added in version 12, from constructor, operation, usability, as well as we continue to actually integrate it throughout the system, as I just showed through our new optimization functions. So we hope that in the coming release, we will add more geometric functionality, and we will be able to extend it and provide you more useful function. And during this talk, there have been several requests about some of the functionality we are considering, and we hope that in the coming version we will be able to provide them. Before I stop, well, I just want to point out some coming talk. We'll have a talk on especially on polygon and polyhedron in June 13, at the same time, 12 to 1 p.m. Central Time, and where we are going to actually dive more deeper into the polyhedron and polygon and polyhedron functionality. And in October, there will be a talk on high school geometry or synthetic geometry we added in this release version 12. And I will advertise a Unity link, which is the interface to the Unity game engine. As you can imagine, it relates directly with our geometry framework of 3D geometry, which should be November 14, and will actually show a lot of functionality, how you can take geometric objects and feed them back to Unity and manipulate them. Okay, well, that's pretty much it. And I believe we'll stop here. There is no additional question in the live stream. And thank you for your time.